Hey there guys, Mr. Carlson here. Let's take a look at an example of writing a balanced chemical equation. So in this problem it says, write the balanced chemical equation for the reaction in which aqueous sodium hydroxide and aqueous calcium bromide react to produce solid calcium hydroxide and aqueous sodium bromide. So for any balanced reaction, it's always going to have the same structure to it. You're going to have the the reactants on one side, the things reacting together. So reactants on one side. What are the things that are reacting together? And on the right-hand side, you're going to have the products. Okay? Now, for the reactants, the way we would write it is you would have, reactant 1 plus reactant 2. And then if there's a third one, you would go plus reactant 3 or a fourth one, and we could keep going. Typically, for most of the reactions that we're going to do in this class, there's probably only going to be like 2 or 3 maybe. And then we do the same thing on the product side. So if you have just one product, you just have whatever product, P1. If there's more than one product, you'd put a plus sign plus whatever the second product is, plus whatever the third product is, however many products that you have, okay? That's the general form that we're going to do. Reactants on the left, products on the right, and we're just putting a plus sign in between each reactant and in between each product, and then we'll balance it from there. A couple other things that we have to be made aware of are different symbols that are used in these equations. Some of these we already know. So like these first two right here, the plus sign, we're just separating the different reactants and the different products. We just put a plus sign in between each reactant and in between each product that we have. The arrow basically is the equals sign, and it separates the reactants on the left and the products on the right. We also want to designate or denote the state of matter that you have for each substance. So we would put an S like this in parentheses next to anything that is in its solid state. We would put an L. I have written here two different ones because sometimes you'll see it written in cursive and sometimes written like this, but it's just a lowercase l basically. And that would show something in its liquid state. A lowercase g for something in its gaseous state, and then AQ like this. That is anytime you have a substance that is dissolved in water to make a solution. Okay, so a lot of times chemical reactions are going to be things that are in a solution of water, and when that happens, we write AQ next to it. Okay, so those are the symbols that we're going to also try to use while we write these chemical reactions. So let's take a look again back at this. And let's first try and identify what are the reactants that I have in this example here. So it says that it is the reaction in which aqueous sodium hydroxide and aqueous calcium bromide react. So that means these two things are my reactants. So I'm just going to make a note down here that my reactants are aqueous. I'm just going to put AQ for aqueous sodium hydroxide and aqueous calcium bromide. Aqueous calcium bromide. And then for my products, problem says that when these two things react, they produce solid calcium hydroxide, so solid calcium hydroxide, and aqueous sodium bromide. Aqueous sodium bromide. So now I've listed out all my reactants that I have. I've listed out the products that I have. Now let's write it in this form. So we actually want to write out what the formulas are for each of these chemicals that are involved, okay? So this is where we have to think back to when we learned how to name and write formulas for both ionic and covalent compounds. You're going to need to remember all those rules about balancing charges and things and polyatomic ions and all of that in order to write out these reactions. So for example, for sodium hydroxide, you need to know the charges of these to balance them out to write out the formula. So sodium, which is in group 1, has a charge of +1. Hydroxide, you may remember, is a polyatomic ion. It has this formula, OH, and it has a charge of -1. So I'm going to start off by writing the formula for that. NaOH, right? +1, -1 means I just need one of each, so NaOH. And then I'm going to put that AQ right next to it. So in parentheses, in the bottom left-hand corner, I'm going to go AQ. And so that shows that I've got an aqueous solution of this NaOH. And then I'm going to go plus my other reactant, which is calcium bromide. Now the formula for calcium bromide I need to figure out the same way. So calcium is in group 2, and therefore it has a charge of +2. Bromide is in group 17, which we know is a charge of -1. So I need 1 calcium and I need 2 bromides. So 1 calcium and 2 bromides for that formula for calcium bromide. And then again, it's aqueous, so I'm going to put AQ next to it like that. And those are all my reactants. So then I'm going to go my arrow. So these are reacting to produce my products over here. So same thing, calcium hydroxide. Calcium we said was +2, hydroxide was -1. So I'm going to need 1 calcium and 2 hydroxides. So 1 calcium. And now remember, when I need more than one polyatomic ion like this, I need more than one of these, we put it in parentheses. So in parentheses, OH, and then 2. CaOH2 for calcium hydroxide. Now that is in its solid state. So I'm going to put in parentheses next to it S. So this is not dissolved in water now, it's solid. And then plus my last product, which is sodium bromide. Again, sodium +1, bromide -1. So one of each, NaBr. And that one was aqueous, so AQ next to it. So now I've got the formulas and the states of matter written for each reactant and for each product. The last step now is going to be to balance the equation. So let's take a look if we are balanced. We might already be balanced, so let's see. I have 1 sodium on the left-hand side, and I have 1 on the right. So sodiums are good. If I look at my hydroxides, though, I have 1 on the left, and I have 2 hydroxides on the right. And same thing for bromine. I have 2 on the left and 1 on the right. So this is an unbalanced equation. Now, one way we can balance it, one way to think of it, is just kind of cutting this in half. And we want the same number of atoms over here as we have over here. One way to think about it is kind of draw particle diagrams, is what I like to do. So I'm going to draw that I've got for this NaOH. I've got a sodium atom and an OH molecule together. CaBr2, I'm going to draw it the same way. 1 calcium with 2 bromines. And then over here, 1 calcium with 2 hydroxides. And then this, 1 sodium with 1 bromine. And so I'm going to kind of balance it by using these particle diagrams to see that I have the same number on each side. So like for example, I see that I've got 2 bromines in this molecule here. Well, I want to have 2 total bromines on the other side as well. And the way to balance that is that I have to have another one of these NaBrs. So I'd have to add another NaBr. And now I have 2 bromines on the right and 2 bromines on the left. So now bromine is balanced. The other thing that needs to get balanced now are my sodiums though, right? Because now I have 2 sodiums and I only have 1 over here. So I'd have to add another NaOH to balance out that. Now those are balanced, and by doing that as well, my OHs are balanced now, because by adding this, I now have 2 total OHs over here, and I have 2 over here. And now everything should be balanced. 1, 2 sodiums, 1, 2 over here, 2 bromines here, 2 bromines here, 1 calcium on the left, 1 calcium on the right. So everything is balanced. And so these are the coefficients then that I'd write. I have 2 sodium hydroxides. I have 1 calcium bromide, so we just leave that blank, nothing there. 1 of these, so I put no coefficient there. And then 2 sodium bromides, so I put a 2 there. And then this would be then the balanced chemical equation for that reaction.